Okay, we're going to be talking a little bit about some rules of exponents, and we're specifically going to be talking about multiplication with exponents. And the things to remember about multiplying any terms, multiplication with exponents is, well, first of all, I always like to start off with what an exponent is. An exponent is repeated multiplication. So if I've got, say, 2 to the third power, this is going to be 2 times 2 times 2, which is 8. Now, notice that I'm not multiplying by 3 at any point in here. I'm multiplying 3 times, but I'm never multiplying by 3. This number here is called our base. And of course, the number up and to the right is our exponent. This kind of notation is something that can be useful kind of as a thought process and might be useful in some scratch work, but won't necessarily be used in any kind of formal work. And of course, our answer is our product. Now, other important things to note are parentheses are very important when it comes to exponents. An exponent, I like to say, exponents only apply to what they touch. Which means that if I've got something like -3 squared, this is not going to be the same thing as, inside a set of parentheses, -3 squared. And the difference is now this is a slightly different way of thinking things. This exponent is only applying to the 3, but not the negative in front of it. We can think of this as, we can kind of think of this as -1 times a 3, or -1 times 3 squared. That's, and here, that negative is still kind of contained inside that set of parentheses. So -3 squared. So now this, if I were to actually, expand this out, this is -1 times, 3 times 3. This is going to be -1 times 9, or -9. That is not the same thing as -3 times -3, and as we all know, negative times negative is a positive. So if you've got a negative sign in front of something, the exponent will not apply to it. I'll pause, and it's a good time to pause and take notes if you are so inclined. Now, let's talk about some of the rest of our rules. We've got, one of the first things we should talk about is like what we call the product rule. And anytime we're multiplying together any two things with the same base, we're just going to add together our exponents. And the reasoning here is fairly straightforward. Because this is repeated multiplication, when I would, with this is just more repeated multiplication. So I will just have this many total multiplications of that base. So say I've got, if I've got, x to the 4th times x to the 5th, okay, this is going to be x to the 9th. And our thought process here, a little thought bubble, this is just, we've got x to the 4th times our x to the 5th. This is x times x times x times x. This is going to be x times x times x times x times x. And grand total, I've got 9 of these suckers. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll have x to the 9th. This is unnecessary work. This is fine just to show it like that. And when we're doing these, it's it's fairly useful to say, oh, well, this is just with two things. What I can do this with multiple terms. Let's say I can do lots of examples with these. I could say we've got, y to the third times y times y to the 11th. Okay. And here, even though this doesn't have an express exponent, I can think of there being an implied 1 right there. So what this is going to be is 3 plus 1 is 4. 4 plus 11 is going to be 15. So this is going to be y to the 15th. And there's my answer. If we can do this with, we could even, and this is something that we're going to run into more later in the next section when we're talking about our quotient rule, and we'll deal with some negative exponents. So you could end up with something like, so we've got t to the 5th times t to the negative 3rd. Well, you can have negative exponents, but in this context, we can just multiply straight across, and 5 plus negative 3 is a 2. So we'll have t to the 2nd power, or t squared. So this is our product rule, and this is pretty common. When it comes to whole numbers or even fractions, it's usually considered good form to, after you've simplified these rules, to go ahead and evaluate them. What I mean by that is, say I've got something like 1/3 to the 4th power. Now this is interesting because this exponent is going to apply to all of the terms inside here. So this is essentially, and I'm going to do a little thought bubble over here. This is going to be essentially 1/3 times 1/3 times 1/3 times 1/3. So this is like 1 to the 4th over 3 to the 4th. So this is 1 to the 4th power over 3 to the 4th power. And of course, 1 times itself however many times is just going to be a 1. 3 to the 4th, well, I'll do a separate little thought bubble for that one. 3 to the 4th is 3 times 3 times 3 times 3. I always pair these up. So 3 times 3 is 9 times 9. 9 times 9 is 81. So 1/3 of the 4th power is going to be 1/81st. A fairly natural extension of this product rule is the power rule. And the power rule, we're only stating our base one time, but this is where we have a power to a power. So here, if I've got x to the a inside a set of parentheses to the b. Now, what's going to happen here is this is where we're going to multiply our exponents. This is x to the a times b. And once again, this is I want to say this is fairly self-explanatory. Remember, multiplication is just repeated addition. So if I had something like, say if I've got like x cubed to the 5th, what this would be, and I'm going to leave myself some space here. I can say this is just going to be 3 times 5. This is going to be x to the 15th. And our thought process behind that is, of course, x cubed to the 5th power. That's just going to be x cubed times x cubed times x cubed times x cubed times x cubed. 1, 2, 3, 4, 5. So literally, I'm just adding this over and over again. 3, 6, 9, 12, 15. If that's not good enough for you, we could, in fact, expand this all the way out and say, okay, this is going to be x times 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 x. And I've got 3, 6, 9, 12, 15. Oh my gosh, we've got it. X to the 15th. So here we go. That's our power rule. And this is kind of cool. We can actually put this together with some other things. So say I've got, so, you know, if I've just doing some examples here, I could do, say, I could do h to the 5th and do this whole thing to the 7th power. No, this is going to be h to the 35th. 5 times 7, 35. I could do something even more exotic. I could say, oh, let's do a 3x to the, let's do 3x cubed, and I'm going to square that. Now I'm being a little bit cagey here because everything inside here is going to be squared. So this means that I'll have 3x cubed times 3x cubed. That's going to end up being, 3 squared is, is 9, and 3x cubed squared is going to be x to the 6th. That one's a little sneaky. Alrighty, I think I'm going to leave that there, and I will see you in the next video.